Fighting with the Hadoop system and fighting with the JavaScript and fighting with the input and outputs as just torture. But really understanding whichever algorithm you pick. And I'm really hoping as each person discusses theirs, it'll be clear and we'll all get it right. So I hope when we leave here, we'll understand 5 or 6 different ones and have some appreciation. And then if nothing else, in an interview or maybe in a job situation, if a problem shows up and you could say to yourself, you know, this is the kind of problem that Hadoop would be appropriate to solve, or this would be a very bad use of Hadoop based on certain criteria. When we get through that, we're going to start into Pig, and Pig is a higher level language that lets you express problems in a way that lend themselves to being solved with Hadoop. It uses this funny set algebra, which is, if you do simple things, it's not too bad, and you try to do complex things, it gets to be a little tricky. I have a Pig text here, which I was keeping track of my steps to install and run my first Pig job, and I didn't have this particular text file last year, but I had no trouble running Pig. This time I got all the way to the end, and it's not letting me, the Pig job starts, and Pig's not able to write its log, which looks like I've managed to install Pig in such a way that it doesn't have write privileges in its own directory. So I'm hoping as we go through it as a group, some of you who know Linux could spot either A, what I should have done differently, or B, maybe we can use change mod or whatever that thing is and fix it at the end. Otherwise, I'll just go fix it tonight and send out mail later. I don't know how far we'll get into that anyhow. But first, I really want you to describe which one you picked, and fundamentally, what is it doing? You know, is it doing a map reduce, or is it doing a map combine and reduce? And you know, like what kind of data is it taking in? How is it processing it? And what data is it spitting out? Okay. And if there are 2 people that did the same one, I would suggest they present together and kind of ping off each other. Okay. So to be totally arbitrary, I'm going to start here and zigzag down. Okay, so which one did you work on?
Word median.
Word median. Okay.
Me too.
And you too?
Yeah.
Okay, so do either of you have any document you would want me to project, or do you just want to scribble on the whiteboard and talk? I'm really not looking for a lot. I'm only looking for a couple sentences. I'm just going to keep asking questions to you until I understand what it did and how it did it, okay?
Yeah.
So, anybody want to start? All right, I'll just take turns asking questions, and you can help your friend out if they're stuck, right? So you did word median, and what does word median do?
It will do mapping and reducer. It acts both.
Oh no, you're going too far.
Okay.
I just want to know, why would I ever want to do this? What is the result I'm looking for?
Okay, it takes the length of each word and finds the midpoint. The median would be.
So if you gave it a list of 25 words, it would calculate the length of all the words, and then it would tell you the median for all these words is 7 letters or something.
Yeah.
Is that it?
Yes.
Okay. Okay. So then, what does it do in the first phase? How do you get from the list of words to the first phase, and what does it do?
It uses a mapper class called word median map. So the class sort of collects the words from both files of the books.
It collects what?
It collects the words.
Oh, in your particular example, you had 2 files?
Yeah. And these files are sort of processed. So the words are processed via the lamp, and looks for the words that are similar based on the median length, and sort of the reducer sums up the codes.
Okay.
Yeah.
So I think I understood that. Maybe you could just say the same thing.
Yeah, well, in the mapping phase, it maps the words into key value pair where the length is the key and it puts 1 as the value. So it takes each word's length and it gives the value for a
So
length.
it could care less what the letters is, it only just, you wind up with a
Yeah.
whole bunch of tuples that are how long the word is in one instance.
Yeah.
Okay, so that's the map phase, okay. And then does it go on to a combined phase, or does it go
Yeah.
straight to reduce?
It goes to the combiner, it combines the key value pairs with the same key together.
Right. So for each subset, you now have a bunch of keys,
Keys,
like
yeah.
6, no, they got like 127 and 2, 192 and 3, 7,000 or something,
Mhm.
where you're having, okay. And then it goes to the reducer, and what does that do?
So the shuffle phase, the last phase, I think, the shuffle phase, where it assigns the reducers and gets all the pairs into one, using the same key onto that reducer. And then in the final, it's outputted as a jar file into a block of memory.
So I would imagine if I looked at the JavaScript code, it would define a combiner. It would define a combiner class, which was exactly the same class as the reducer class, right?
Yes.
Yeah, because that was just like the one we did in class.
Yeah,
right?
but I had one question. So in the combiner class, sometimes it may run 0 once or multiple times. So what happens in the reducer then if it doesn't
What
run?
does it do multiple times?
The combiner, when it combines the key and value pairs,
Yeah.
if, like you mentioned about the subset, so
Yeah.
in case if it doesn't find a same key, or if there's no subsets, so maybe that would be like an individual one. Getting it?
Let me describe what I would assume it does and see if you can use my words to tell me what it's doing if it surprises you, right? So it's going to, one process is going to come up with like one, and one. I guess these are not square brackets, I think they're just regular old braces. So we'll do a really simple one. I think it will be something like 1, 1, 1, 1, 1, and then maybe there'll be a zillion of those, and eventually it'll get to 2, 1,
Yeah.
2, 1, and then there'll be a whole bunch of those, and then there'll be 3, 1. And eventually, if we fed it something that only had 3-letter words, we would have N of those and Y of those and Z of those. And that would be the mapping phase, where you're basically, you're mapping the data along some criteria. You're creating a tuple for each one that you find, and then you're doing that. And then in the same node, you would go to the combiner phase, which would just combine those, and then you might wind up with like there are 27 words that had 1 letter, and then maybe there were 16 words that had 2 letters, and then for 3 letters you might have had 14 words. And this would be on one node. And then if it, I think you said you had 2 documents went in it, so it probably would have pretended like it sent one doc to one and one doc to the other. So the other one would sort of be doing the same thing, and let's say it come up with 113 and 212 and 319. So each of them would run across all their data, create a bunch of onesies, calculate them into matching sets, come up with the twosies, and then these would both be fed to the reducer, and the reducer should have, I think, just combined like keys, and then added a value, so then it would say 1, whatever that is, 40, and 2, 38, and 3, 33, or something like that. Maybe that's a 43, I don't know. 20 and 14, yeah, that's 33.
Yeah, that's correct. The data nodes actually coordinate the replication.
You what?
Both the data nodes coordinate the replication to avoid repeating the same.
What does it do when repeating?
They coordinate the reputation, like repeating words.
Oh.
So both data nodes actually coordinate that. So you're not repeating words.
What phase does it do that in?
That's the last phase.
In the last phase. But in the last phase, you wouldn't have words. You only had words in the first phase when you counted the letters. Then the words are gone. And then you have these tuples. No, you said you had a problem with zeros or something?
Mhm.
What did you have?
So if
I mean, I could imagine if we had, let's say we did the combining and we had, for 5s, we had 6, and by some chance there were no 4s,
yeah,
maybe you get a 4-0?
yeah, that was the thing I was. So now how would it do it on the red user phase? Like, if it is the same, then it would count them. But if it is not the same, so will it just add it up with the word, or how is that for the list?
You're still talking here, because what I'm hypothesizing here is there's no 4, and let's say this is a 5-2. There's no 4. And
Yeah.
This is a 5-4.
So now for the 5-2 and 5-4, we would write it as 5-6.
Right.
Right? So now the 4 is being left out because we don't have any
Right.
thing.
Right.
So
Oh, and you're saying that's what you're saying. You're saying some were missing,
yeah.
and that would make sense if there were none that had that value.
Yeah.
Okay? So again, if you were doing this across 150 books and you could spread this across 150 processors, all things being equal, it would run 150 times faster than if one processor tried to process it at one, right? There's an expression that I won't get quite right, but it's something like ridiculously simple parallelism. I don't think ridiculous is the word, but it's literally a phrase you'll see in all these kind of documentation. And it says, some problems with tremendous amount of effort can be programmed to run in parallel. And some are just, they're obviously parallel. They're ridiculously simply parallel. So this would be an example where you're going through 100 books. You want to get the median count from all the books. Why not spread it out to 100 people? Okay? Okay. Does anybody want to volunteer to go next, or should I just pick?
I can go.
He said first.
So
Which one did you do?
I initially picked the Sudoku,
Yep.
but for one reason or other, it couldn't ever find the file.
I
So
know that problem.
and it made no sense to me. So I switched over to the Pentamine problem solver.
Which one?
The Pentamine.
Pentamine?
So if you think of
Is that
Tetris,
something they eat in Australia that's made with?
could be. So that's the one where like you have Tetris blocks that you want to try and make into good squares.
Is it like, to jump ahead maybe, is it more like the guy packing the UPS truck trying to get as many boxes?
That's kind of the scenario that I'm thinking, or for graphic designers, or for somebody who's trying to do like flooring tile layout. The description is, where is it? Solve one side pen. So it's this one comes with a 9x18 board.
Oh. So it looks like a checkerboard that's 9x18?
Right. And it's a generic model for problems such as tile placement, where all the valid choices can be represented as a large sparse Boolean array. So what it does is it takes and it maps out everything, and each row is given a prefix number, and it's based on the shape of the tile.
Are the shapes all perfect rectangles, or
No,
they're completely? what are
no.
they?
So they can be like a T shape. They can be like a, kind of like a weird S shape, or
Oh, but so if it's like an inverted T, then like if that would be an extension of a square,
right.
it's going to try to put it in there, not just up against it.
Well, and then it's going to try and match whatever will fit. So what it does is it goes through all the puzzle pieces, and it figures out which sides can match to each other to make squares, and then it comes back and it says, okay, all these things match, and they're now all true. So now we're going to take the ones that are false, we're going to try and match them together again until they all become true, and then we're going to take them all together and then blend them together and make everything equal true against all sides.
All right, I'm not sure.
I don't
understood
fully-
that, but let me draw a picture to make sure we understand what you're saying.
I don't fully understand the entire process just because of the odd shapes.
No, that's not what I want. So it's got 100 of those and 300 of those and 2 of those and 6 of those or something, right?
Right.
And you're saying the first thing it does is before it deals with actually trying to place anything, it's finding like compatible partners.
So the very,
It will go and it'll figure out that if I put that one in there and that one in there, I'll have a perfect rectangle. And if I put 2 of these here, I'll have a perfect rectangle.
that's my understanding of it, is of how it works. And so,
So then let's call this A, B. This is shaped A, B, C, D, E. So the first pass, it says A plus B plus C is good. And then it says D plus E is good.
so my understanding is the first thing it does is, so if this is kind of like whirlwind block or square would be, right? It would give this whole thing a prefix of say 1, and that would represent that shape. And then, so the next thing it would do is it would take this shape, right? And then say give it a prefix 2. So it tries to match up all the prefixes to make it equal true. So all the ones are in line, 1, 2, 3. And then what it does is for anything that doesn't equal true, it'll go back through and remap it all. And it initially starts off by going into 2,000 different block chunks. So I started mine at 6:30 last night. It's 11% done right now. It's still running on one node. So it takes it quite some time. On top of this single
Why
node.
is this called a 1? Or is this totally arbitrary? Is this just a name?
That's it. All it says is it takes each column or each row and gives it a prefix so that it has something to compare against. And it tries to line up everything so
So
that
then it's
true.
saying, it's not 1, 2, 3, it's 1, 1, 1?
That's how I understand it. I couldn't find a whole lot of great documentation. Everything points back to it's based off of Tues or Tues
Yeah.
algorithm, dancing length algorithm. And
So when it's done, does it take a set of shapes and like try to basically, like, it fills all this in with no holes and then maybe there's some space left? Is that the idea?
I believe so. And then for anything that is asymmetrical, the program will take it, flip it front to back, because now it's a whole new set of, it's a whole new shape, so to speak.
Mhm.
So then it'll
go through and